Okay, almost done with this packet actually, and we're going to start doing some calculations of molarity and dilutions on page 12. You will need a calculator to do these. Any kind of calculator will work for this. Luckily, it's just multiplication, division, maybe a little bit of addition or subtraction mixed in there. And technically, all of the equations we need are on that equation sheet, and the solutions unit has their own kind of reference section down here, but these are the only two equations that we're going to need in here. And so right now on notes, you probably won't need this for this podcast, but I would recommend that you practice using this because that's going to be our standard that we use from like on tests and quizzes and such. So use it, find it so you have the equations and that you know how to rearrange them, because that's really all that it comes down to. So first we're going to focus on this equation, our molarity equation. And molarity, if you don't recall, is how we calculate concentration, how much stuff is in a certain amount of space. And we've seen this a couple of times maybe, but we haven't really dug into what it means yet. So this is where we do. Molarity is technically a unit that is how much stuff, how much of our solute, which of course we're going to measure in moles, divided by how much solution we have, how much space that stuff is dissolved into. So this is kind of sort of like density, but instead of grams per milliliter or liter, it's moles. So it just tells us how much is dissolved in a certain amount of space. Now, you might see this in a couple of different forms. We could simplify this down to get rid of some of the extra wordage into M for molarity, and it does need to be a capital M for molarity is equal to moles over liters, and this is actually the way that you'll see it on your equation sheet too. But moles we've seen before, the actual variable, and it kind of only bothers me a little bit. This isn't actually the variables. We've used variables before for moles and liters. It's N and V, and that helps us when we see this next equation we're going to be using just a little bit to see that as a V. N doesn't necessarily have to be N though, so I kind of use a hybrid method when I'm writing this out most of the time, and I say M is equal to moles over volume. But I'm going to stick with what we see on our equation sheet for now. I'll come back to that triangle in a second, because it is a good reminder. These are our units, and we don't usually put units into an equation, but molarity's units is just that big capital M. Moles is, of course, moles, and then our volume has to be in liters. And if you remember our gas unit, to go from milliliters to liters, we have to move the decimal place 3 times to the left. I'm going to say move decimal. So you might want to make a note of that because I get asked that a lot. We do have to use liters here, and you will often be given milliliters because that's how we commonly measure things. So that's our equation. What that weird triangle thing was how I'd recommend, it's just algebra to rearrange this equation because we're going to be solving for moles, volume, whatever, a lot. But some of you who struggle with the algebra, I'm going to give you a trick for rearranging this equation. Draw a triangle, maybe in that corner where you haven't written much, and put this little grid in it. And then we're going to put these variables into this grid. And what we need to know, molarity is moles over liters. So that has to be moles over liters. Whatever space is left is where I'm putting that molarity. So all we have to do in order to be able to rearrange this equation, let's say I wanted to solve for moles. Then I can cross out or cover up moles, and what's left is my equation. So M and L are next to each other, so moles is equal to our molarity times our volume in liters. If, on the other hand, I wanted to solve for volume, and I said how much what's the volume of a solution with this many moles and this molarity, then I have moles over molarity. So my volume is moles divided by molarity. And of course, the original equation that we see written out that will always have molarity is moles over liters. So you can just cover up whatever you're looking for. It's like playing hide and seek. It's like, what's this? I don't know. Cover it up and then you'll find it. So I'm going to have that at the corner of all of our problems just to remind you how and why I'm rearranging things, but I'm not going to spend a whole lot of time on each problem going through how did I rearrange it. If you need help with that basic algebra and getting the equation that you need, ask me for help. So This first question asks us for molarity, so I already know I'm going to be doing molarity is moles over liters. And it gives me milliliters. 355 milliliters is going to be 0.355 liters. So that's going to be my volume, V, in liters. And then I don't have moles, it gives me grams. And you know what? You're going to have a lot of problems that give you grams here. But every time you see grams, it means you need to turn it into moles. If a question asks you for grams, you know you got to find moles first. That's kind of second nature. We've been doing this for a long time now. There's that basic grams to moles and back again. So you need to be prepared for that. That's going to be more questions than not. So real quick off to the side, I'm going to take that 40 grams, and that's glucose, C6H12O6, which if I add all of the masses of those elements up on the periodic table, that's 180.156 grams per mole, means 1 mole goes on top. And that actually gives me 0.2220, but I'm just going to keep these 3 sig figs. Moles. So that's my moles. I found moles first because I knew I had grams and I had to get rid of them. And now I can actually get to plugging this in. I have that many moles, and we already changed our volume into liters, so that's 0.355. And putting it in the calculator gets us 0.62535. And that means our final answer is 0.625 molar. That is the concentration of that solution. So just a little bit of algebra, maybe a little bit of dimensional analysis, and you're there. Just to make that look the way I wanted it to. It's not too bad. The dimensional analysis is probably your least favorite part there, and if you look at our next question, it asks us to find the mass of our solute. So I'm going to be doing some dimensional analysis again. I see mass, I see grams, I'm going to have to do it. And if I know I'm going to grams, I need to find moles first. So if I know that I am solving for moles, I am going to have to rearrange this. But if what I'm looking for is moles, then I'm going to be taking the molarity times that volume in liter. So moles is equal to my molarity, 1.75. My volume's already in liters, so that's going to be 2.50. This part's pretty simple. That tells me that it's 4.375, so that's going to round to 4.38 moles. Now, it didn't ask for moles, it asked for grams. So now dimensional analysis time. If I add up barium nitrate, and just so you know, barium nitrate, it looks like this. So I'm adding up 1 barium, 2 nitrogens, and 6 oxygens. And that got me 261.336 grams per mole. So the per mole part, the 1 mole goes on bottom, and then that 261.336 grams goes on top. And then that will get us our answer when we multiply those two numbers, and that's 585.795, which would round to 586 if I'm keeping 3 sig figs there. So that's how much stuff I'd have to dissolve. Very, very simple process, and this is exactly how we make solutions. I have to do these calculations all the time to be ready for your labs. So let's look at one that doesn't involve dimensional analysis, because they aren't all. This one says to calculate volume, so I'm already thinking and looking, this is my volume here, that's measured in liters, and that volume, or my liters, is equal to moles over molarity. This is what's left over here. So moles is given to me for once. Don't get used to it, but sometimes it happens. And then my molarity was 0.125. Divide it, and that gets me 2.936. And keeping 3 sig figs, because each of those other numbers had 3 sig figs. 2.94. This is volume, which has to be measured in liters. So that answer will be liters. Next one. Calculate the molarity. Okay, that's nice. This is just a normal molarity equation. Don't have to rearrange it at all. Moles divided by liters. It contains 15.5 grams. Oh, I'm going to need to do some dimensional analysis. And then 250 milliliters. I know I have to change into liters, so that's going to be my volume here. So that, I need to do my dimensional analysis real quick. Take that 15.5 grams. Silver nitrate weighs 169.872. And 1 mole on the opposite side. And then 0.09124. 0.09124. And it keeps going a bit. But I'm going to just round that and keep that as 0.0912, keeping those 3 sig figs there for my moles. Making that a little smaller because that's not my final answer. So now I get to plug that in. Oop, almost forgot my 0. And then my liters was 0.250. And this turns out to be 0.3648. So this is going to be 0.365. This is molarity. So it gets a big capital M. So we've solved for a little bit of everything in here. Sometimes they do involve dimensional analysis if they mention grams. Sometimes they don't, but that's really as complicated as they get. And I would expect to see a few with dimensional analysis. Now, our second equation is a little bit bigger, but it looks a little familiar. This is kind of like our combined gas law, except there's no denominator, so it's going to be pretty simple to solve. This is also given on your equation sheet, although you really shouldn't need it that much, especially after I talk to you about rearranging this, because no matter what I solve for, let's say I'm solving for M1, I have to divide by V1 to get it by itself. So the equation would look like this. If we're solving for V1, I'd have to divide the opposite side by M1. Even if I'm solving for that stuff on the other side, look at the way these equations break down. We're always taking whatever stuff we have both of, whatever we have complete information of, the molarity and the volume of a specific solution, and then dividing by whatever we know about what we're looking for, our unknown. So dilutions is when we're adding water to something to change its concentration. Like you might dilute orange juice and stuff. So there's always going to be a change happening. This is why it's like that combined gas law. As we're starting with a specific solution with a certain molarity, a certain volume, and then it's going to change. And so you're always going to be able to tell when to use this equation by looking for if something is changing. But now we just have to deal with M and V instead of P, V, N, and T. It was a mess. So this is like what we said back then. If you're really looking for a simple way to remember how to rearrange this equation, whatever you're looking for, take this stuff on the opposite side, whatever you have both of, and divide it by whatever number is kind of by itself. So when we're looking at these problems, it's important to label your numbers, and then I'm not really going to go through much algebra here either. I'll just write out the numbers and what I'm doing with them. Okay, so reading through this, first thing it asks what concentration? Concentration is measured by molarity. So I'm looking for a molarity. I'm just not sure which one it is. So let's keep reading and we'll find out. It says, what concentration results when water is added to 500 milliliters of a 12 molar solution? So this 500 milliliters is my volume. Here's my other concentration. Since that's the first volume I see, I'm going to make it V1, which means this needs to be M1. These two numbers are talking about the same solution. I have 500 milliliters of what? Of a 12 molar solution. So it doesn't really matter whether they're M1 and V1 or M2 and V2, as long as they go together. Then I see this other volume here, which is V2 for me. So that does mean I am looking for M2. Now, normally it does not matter that volume is in milliliters, but the only thing that does matter is that they match, that my V1 and V2 have the same units. It could be teaspoons for all we care, as long as they match. And unfortunately, these don't match. So let's go ahead and practice that skill we've been working on of turning milliliters into liters by moving that decimal 3 times to the left so that these units can match. I'm generally going to leave those milliliters as milliliters, though, because I don't want to change anything and risk doing it wrong if I don't have to. Just like the combined gas law, it does not matter what units we got as long as they match on both sides. So in this situation, whatever we're finding, this is case M2, is equal to whatever numbers we know multiplied together. So whatever we know both of, and that's going to be my V1 and M1. And even though our equation technically said M1, V1, I think our equation sheet actually says V1, M1. It doesn't matter the order. So just find the numbers that go together and multiply them together, divide by the other one. And when we put this all in our calculator, we actually get the answer is 3. Now I need to make sure this is 3 sig figs because all of those numbers had 3 sig figs. So that's going to be 3.00 molar solution. The word is molarity. That's what we're measuring, but we measure it and we usually say molar, like the tooth in your mouth. So that's a 3 molar solution. You can say 3 molarity, but it just doesn't sound right. That's not what a chemist would say. So, first problem down, just multiply and divide. Our next question is same idea. I get a molarity right off the bat. I'm going to call that my M1. Don't really have a lot of space to label these things. M1 says that much molarity of our sodium chloride solution is diluted by adding 35 milliliters of distilled water to 50 milliliters of the solution. So I've got this solution and I've got 50 milliliters of it, in fact. So this is going to be my V1 as well. Now I might come over here and say that this is my V2, but I'd be making a mistake. The last one mentioned that I was adding water to a solution, but it didn't ask me for the final volume of that solution. This one I am going to have to, it says I'm adding this much water to this other solution. So I need to add this number to that other number that I have to find the final volume. So just a little bit of kind of side work here. I'm going to point to that and write down what I'm saying. My V2 isn't that number. My V2 is equal to my V1, which was 50, plus this water that I added to it, which makes this 85 milliliters. And those milliliters are just fine like that because the other volume I have is in milliliters. So these are my numbers. I know my M1 and my V1, and so looking for my M2. And I'm going to take my M1 times my V1, and that's going to be 3.34 times 50. And divide by that 85 number. Gets me 1.9647, and that rounded to 3 sig figs again is going to be 1.96, and that is our molarity, so we put a big M on it again. So you have to read these carefully. That's really the only trick. You have to find what variables are which, get the right numbers multiplied together, and then make sure that you don't have to add some water in to the other numbers. Now, 7 is the last one, and it's similar to what we just did, but it's kind of the opposite. This is asking us how much of our solution and how much water will need to be mixed to get us to a final volume of 750 milliliters of this concentration. So I see my volume. Oop, not what I wanted to do. I wish we were done. This problem's a little bit weird. So here's my volume 1, here's my M1. I want to find a volume 2. It's because it's asking for milliliters, but I'm also going to have to find how much water is needed to get it to that volume. So what this is talking about is in order to get this much of this solution, so in order to get that V1, I'm taking whatever original volume of that 12 molar solution I have and adding some water So this is going to help us later because we're going to be wanting to find that volume of water. So in order to get that final answer, once I know my V2, I'm going to have to be subtracting that V1 minus V2 is going to give me my volume of water, because that's how much my final solution had in it minus how much of my solution I started with. So let's solve for that V2 real quick. Take that M1 times my V1, 750 times 1.11. Put that decimal back there to remind me that that is 3 sig figs. Divide it by that 12 number, and that tells me that my molarity, or my volume, is going to be 69.4 milliliters. So that's my V2. So that's one of my answers. That's how many milliliters of my solution I need. And now I'm going to subtract to find my water. I'm going to take that 750 milliliters and subtract that 69.4 milliliters. And that gives me a final answer of 680.6 technically, but I'm going to round that to 681 just to keep those 0 decimal places. So it's about 681. It'd probably be a little bit less, but sometimes solutions aren't perfectly additive, but you'll talk about that more if you end up taking AP chemistry. So those are my 2 answers. Sometimes the only thing that makes these tricky is that we might have to do a little bit of addition or a little bit of subtraction based on what we're reading in that problem. So keep an eye out for that. Now, you are going to be practicing on pages 13 and 14, like I spoiled the surprise earlier when I clicked to it, but we get to skip a couple of problems, so make sure you cross those off. I'm still posting all the answers to all of them, but those are either a little bit repetitive or have you do some weird stuff in them. So ask me if you have any questions. These are a mixture of both types of equations. So there's a little bit of molarity in here, a little bit of dilutions. You need to be looking. Anything that's talking about changing the solution, it says, first I started with this solution, then I added water, or I diluted it. Or it might just say, and then I want to make this other solution. If there's a change involved, that's when we're using that M1V1 equation. If there's no change happening, then you're going to be using the molarity equation, just moles, volume, molarity. So first things first, for each question, choose your equation. Even if that's all you can do, that's a good start. I have all of those equation choices written on my answers too, so go check those before you start putting in the numbers to make sure your plan is correct. Because if you got the wrong equation, you're going to get stuck and frustrated and never going to get there. So let me know if you have questions, check your work, and come say hi in that live podcast. Technically, you could cross out the entire page 15 as well. We're not going to be doing Beer's Law stuff. I'll remind you of that later, but your next podcast is going to be starting on page 16. So good luck and enjoy.